Hey guys, what's up everybody? Welcome or welcome back again to another video tutorial from the Apex Academy of Mathematics. We're learning the language of the universe begins here. My name is Akeen, otherwise known as Apex Selenium, and on my channel we help to rebuild students, we unlock their genius, and we help them to master their fundamentals. And in this video we are going to be talking about solving exponential equations. This is of course a video that is connected to the laws of indices video, which of course a link is provided in the description below, so do check that out. All right, but before we jump into this video, if it is that this is your first time here on my channel, or you have been here and you've watched other videos and you like the content, please of course go ahead and support my channel by hitting the like button, of course smashing the subscribe button below, and turning on your post notification bell for future tutorial videos. All right, so without further ado and rambling, let's jump right into the video, and hopefully this will be to your benefit. All right, okay, so let's go. All right, so we're talking today about solving exponential equations, and of course right there, as you can see on the screen, I've written the law for you here, and the law here clearly states here that if some base raised to some power m is equal to some base, which is the same base as over this side, is equal to some power n, then once we have the same base and we are dealing with an equation or even an equation, then the powers are going to be equal. All right, and then we can solve the equation. So this expression here, this thing right here in black, will make a lot more sense to you in a moment. All right, good. So let's look at some definitions, some notes here, and so let's see if we can have an understanding before we get into the juicy part of the video. All right, so I want to remind you of something though. An exponential quantity is a quantity that is raised to a power. All right, which of course this should be which can be an integer or a rational number. All right, so I want to revisit something for you. You can have an exponential quantity that may be an algebraic term, let's say x to the power of a half, or it could be x squared, or it could be x to the minus 5. So it could be a negative integer, it could be a positive integer, it could be a fraction. All right, that's an exponential quantity. Now the quantity, the base here, may not necessarily have to be x. It could be y, it could be a, it could be p, it could be q. It could also be a numerical value like 5 to the half. It could be 5 squared. It could be 5 to the minus 3. All right, so the base here does not necessarily have to be a letter or a symbol, but it could be a numerical quantity or a combination of both. All right, good. So I wanted to make sure that that is clear if this is the first time you're watching this tutorial video. All right, next we're going to move on to the steps to what we have to do in order to solve an exponential equation. All right, so for students doing CAPE or students doing EDXL exams, GCE exams, or even college and university maths, you're going to definitely need to watch this video, because you're going to see a lot of exponential equations, especially if you're doing college algebra, pre-calculus, calculus 1 and or 2. Okay, all right, so let's get into the basics here. So in order to solve an exponential equation, all the quantities in the equation must have the same base values. All right, so you're going to be getting a bunch of equations where the bases are not necessarily the same, and then you are going to need to convert them to be the same. All right, and that skill of changing bases, of course you can watch videos on my channel on how to simplify exponents, as well as change of base and solving, well, not solving, but changing bases and manipulating exponential quantities. Do of course check the description box below for a link to my videos on that. All right, so once we have them in the same base, then we can apply the necessary laws. All right, now for this video you're going to mostly see me using the multiplication property and the power to power property, but there are examples out there that utilizes the division property. All right, but most of all you're going to be seeing me using the multiplication property, the power to power property, and the equal base property. This is called the equal base property. A to the m equal a to the n equal, then m is equal to n. All right, so we're going to be using these three laws most of all, but don't be fooled. You can see examples with the division property, so do check that out in your textbooks and practice papers. All right, so the examples, well, on the next page, not below, but on the next page, will demonstrate the application. So let's get into that right now. I do have some examples here for you. All right, this is quite a hefty set of examples, so let's see how best we can work through these as quickly and precisely as possible. All right, so the first question that we have here is, of course, to solve for x, and here what we have is 4 to the power of 3 minus 1 is equal to 64 multiplied by 4 to the power of x. So we need to solve the equation for x. All right, of course, most of the time what you're going to find out is that the question will say solve for the unknown value which is in the power. So we normally refer to this topic as being solving for an unknown where the unknown is in the power. All right, so if you do see that in your textbooks, of course, you know how that goes. Okay, so let's get into it. So what we're gonna have to do here is that we have the lowest base here, which is 4. All right, so we need to turn this 64 into a base 4. So what number can 4 be raised to in order to get 64? Of course, you need to know your manipulation technique and your powers, square tables and cube tables. So without further ado, we know that this is already in base 4. So this is 4 already to the 3x minus 1, and that's equal to this now number here is 4 to the power of 3. All right, so if you don't know that, then of course visit the videos that I've made on how to convert numerical values into exponential quantities. All right, and then this is times 4 to the x. Okay, so there isn't anything much that we can do on this side, but here we have the same base over here, and this is the multiplication property. So the rule states that we're going to have to add the powers. All right, so this is 4 to the 3x minus 1, and that's equal to 4 to the, and here's a very common mistake. A lot of students will say 3 plus x is 3x, and that is grief. You do that, you're going to be in big trouble. All right, remember that in algebra you cannot add unlike terms. So this is a variable, this is a numerical quantity, so 3 plus x will be equal to 3 plus x. Okay, so please do not say 3x. That's a very big mistake. All right, now if you look carefully here, is that you can apply the equal base law here because the bases are the same. So this is represented by a, this is m, this is equal to a again, and this is a n. So let's write it here, a to the m is equal to a to the n. The rule states from the first page when we just started the video that m is equal to n. So since as we have the same base 4, we can just take the powers, which of course the power over here is 3x minus 1 and the power over here is 3 plus x, and we can equate them and solve. All right, so we're going to go over here, right? 3x minus 1 and 3 plus x, so 3x minus 1, and that's equal to 3 plus x, and then we're going to do our regular equations and solve. So here we have 3x. We're just going to bring this x over to this side here, and then this is a positive x, so it comes over as being minus x, and then we're going to have this positive 3 over here and bring this minus 1 over there. You're going to get 1, positive 1. So 3x minus x is equal to 2x, and 3 plus 1 is equal to 4. All right, so dividing both sides by 2, let me just rewrite that a little bit. So 2x, so we have 2x divided by 2, and that's equal to 4 divided by 2. We find out that x is equal to 2. All right, so do of course search my videos on my channel or look in my playlist. You're going to see a bunch of videos talking about how to solve equations. So if this is a problem here for you, check those videos out. All right, I will try to provide a link in the description below for you. All right, so with that said, the value of x for question number 1 is that x is equal to 2 for that one. Right, fantastic guys. So I hope you got that one. Let's check out number 2 over here, where this time we're not dealing with just 3 quantities, but we're dealing with 4. All All right, so let's zoom up here and see how we can work out this question here. All right, so what we have here is 7 multiplied by 7 raised to the power of 3x minus 2 is equal to 343 multiplied by 7 to the power of 2x. All right, now there are some terms here that do not have a power, and there is one here that is not in base 7. So when we see a numerical value with no visible power, then the power here that is understood is a power of 1 right there. Okay, so now we have a power, and 343, if you know your cubes table, you'll know that this is going to be 7 cube. So we're going to rewrite this expression here to look a little bit neater. We have right here we have 7 to the power of 1 multiplied by 7 to the power of 3x minus 2, and that's equal to 7 cube multiplied by 7 to the 2x. All right, now that everything has the same base, what we're going to be doing here is that on this side here we have the multiplication property where the bases are the same, so we're going to have to add the powers. All right, so adding the powers, now we're going to get base 7, and that is 1 plus 3x minus 2. All right, okay, so that's minus 2. Okay, perfect. And then that is going to be equal to another multiplication property here. The bases are the same, so we're going to be adding the powers. Now, again, another mistake is that students will say 3 plus 2x is 5x. Oh, please, that's grief. Do not do that. Remember, this is a 3 numerical value. This is a 2x. This is an algebraic term. You cannot add terms that are unlike. So 3 plus 2x will be equal to 3 plus 2x. All right. Now, if that is where you reach in the problem, then at this stage here we can apply the equal basis law, where what we have here is that 7 and 7, and we have a power here of 1 plus 3x minus 2, and we have a power here of 3 plus 2x. So we can definitely just go on the next page here. Let's copy this. This is good. 1 plus 3x minus 2. All right, let's just erase this page here. Okay, so this is 1 plus, let's write a little bit. Okay, so that's 1 plus 3x minus 2, and that's equal to, let's go back to this page over here where we have 3 plus 2x right here. Okay, so that's 3 plus 2x. All right, so to solve this equation, now all we have to do is just get the x's on one side and the numbers on the other side. So we're gonna have here for you 3x is already over here. We're gonna bring this 2x on that side, so we're gonna bring that 2x over here. So we have minus 2x, and we're gonna be equating this to 3 is over here. We're gonna bring this minus 2, and it's going to become positive 2, and we're gonna bring this positive 1, and it's going to become minus 1. Okay, so 3x minus 2x is actually equal to x, and of course 3 plus 2 is 5, and of course 5 minus 1 is 4. So what we're seeing here is just a basic equation, and of course we have just learned here that the value of x is that x is equal to 4 here. Okay, all right, so that takes care of that problem, that exponential equation. I don't think that was too bad. So if you're understanding the content so far, the concept, please of course drop a like on the video. Right, I don't mind the support at all. Let's jump into example number 3 and 4. Now with example number 3, I've just changed a little bit where I've put it into a fraction form. All right, so let's see how best we can look at this to our benefit here. All right, so here we have a base 5. It has its power. It's the power in an algebraic expression, but we have this base here that is not in base 5 nor this one. Okay, so we need to turn these into base 5s. So what we have here is that we have 5 3x minus 4, divided by, you know your square tables, that 25 is actually equal to 5 squared, and then that is equal to 625 is going to be equal to 25 squared, but 25 is not in base 5. So if you know your fourth power table, then you know that this is 5 to the power of 4. Okay, all right, wonderful. Now what we can do here is just put this over 1, and we are going to do the cross multiplication. All right, we can cross multiply once we have a 1-to-1 ratio. All right, 1-to-1 ratio. So let us do that on the other page. This is, let's copy this section right here. 5 to the 3x minus 4. Let's clear this. So we have 5, okay. All right, so we have 5 to the 3x minus 4 divided by 5 squared, and that's equal to 5 to the power of 4. So by cross multiplying here, we're going to have 5 to the 3x minus 4, and when you times anything multiplied by 1, you're going to get the same thing. All right, so that is called the multiplicative identity. Anything multiplied by 1 will give you the same thing. So we're good to that point. And then we have 5 squared times 5 to the 4. Let's write that down. So that's 5 squared times 5 to the 4. All right, now another mistake here is that students will say 5 squared times 5 to the 4th is 25 something something. All right, so remember, this is exponential quantity. You do not multiply the bases, you just write them down. Okay, so what we have here is that we have 5 to the 3x minus 4, and that's equal to, the bases are the same, so we just rewrite the base and we're going to add the powers. So that's 2 plus 4. Okay, all right, so this is the multiplication property of indices. So what we have now is just 5 to the 3x minus 4, and that's equal to 5 to the power of 6. Okay, now right clear, then you can see that we have equal bases, so we're going to be using the equal base property, which we discussed earlier. When the bases are the same, then the powers are basically going to be equal. Okay, so we're just going to bring the minus 4 over here, so we have 3x is equal to 6 plus 4. All right, and then what we have now is that 3x is going to be equal to 10. So this works out nicely to be that 3x divided by 3 is equal to 10 divided by 3. Of course, x is equal to clearly 10 over 3 as our answer. All right, so not all the questions will have answers that come out real nice and smooth, but you may have any value. But most of the time when you get questions like these, the answers come out real nice. But take note of this one. All right, so this is a fractional exponential equation. All right, so if you have any problems with the equation, do check my video to see if there's a video on equations, or check the description box below for a link to those videos. All right, so hopefully you got that one, guys. I hope you guys are enjoying the content so far. So let's proceed into the fact. Oh, let's make a note here that x is equal to 10 over 3 for that one. All right, so we have 1, 2, 3 more examples, and I really want to go through all of these because I want to make sure that you have all of the concepts locked down. Okay, we want to go through as much as we can, so please watch this video to its entirety, or take a break and return to the video if you have to. All right, so what we have here is 64 multiplied by 8 raised to the power of 2x minus 1 is equal to 512 multiplied by 8 to the power of x minus 3. All right, so it's more or less similar to, of course, the example above here. Is just arranged differently, where this base was on this side, what the base is on that side. Now we have two numbers that we have to do a conversion for. Okay, all right, so let's get into it here. All right, let's first erase this page, and let's go back over here, zoom it up, and we're ready to go. All right, so 64. All right, we need to get this in base 8, so we know that right away 64 is going to be equal to 8 squared multiplied by, of course, this is already in base 8, so that's 2x minus 1, and of course we know that 512 is going to be 8 cubed multiplied by 8 to the power of x minus 3. Okay, so now that everything is in the same base, we're going to apply the multiplication property. The bases are the same, so we are going to add the powers. So we end up with 8 to the power of 2 plus 2x minus 1, and that's equal to, over here we're going to apply the multiplication property, so this is 8 to the power of 3 plus x minus 3. All right, very good. Now we can also do a little bit of simplification here to just make this a little bit neater. So we have this positive 2 and we have this minus 1. So what we're going to have is just 8 to the power of 2 minus 1 is 1 plus 2x. All right, so guys, please do not say 1 plus 2x is 3x. Remember, you cannot add unlike terms. So this is 8 to the power of 1 plus 2x, not 8 to the power of 3x. Okay, All right, good. And over here we have 3 minus 3, so that's basically the additive inverse identity. 3 subtract 3 is 0, so we end up with a to the power of x. So we have reduced our expression down to 2 bases here and its individual powers. All we have to do now is just to go to the next base, so that is 8 to the 1 plus 2x. So 8 to the power of 1 plus 2x, and that's equal to, let's go over here, and we have this is going to be 8 to the x. Okay, so that's 8 to the x. All right, so now that the bases are the same, we have the equal base property. So we have right here 8, and then we're gonna well, okay, we don't have 8, we have base 8, so we're just going to equate the power. So that's 1 plus 2x is equal to x. Okay, all right guys, so now that we have that, we can do a little bit of transposition. We have x over here, we're going to bring this x over here, so we're going to get minus x, so that is going to be 2x minus x, and that's equal to, this 1 will go over there and it will become minus 1. So 2x minus x is equal to x, and x then is equal to minus 1. So that's nicely done. All right, so that's a nice put together piece of work. It's quite lengthy, but as you can see, if I can manage it, I'm teaching you exactly how you can also do that for yourself. Okay, all right, so let's write this down, that x is equal to minus 1. All right, so we have 3 more examples and we want to quickly run through these. All right, so for this one, it's not that difficult. Based on the other 4, this is far less harder than the other one. So this is easier here. 64, 4, we need this to turn into a base 4. So just like the example up here, where we converted this 64 here to 4 to the power of 3, we can do the same thing here. So this is 4 to the power of 3. Now watch this. Here we are expressing 64 to an exponential quantity, but remember that there was already an exponent, and that exponent was a binomial expression, so we're gonna have to put that in a bracket like that. Okay, so 4 to the power of 3, that's 64, but it's already raised to a power of 3p minus 2. All right, so just gonna take care of that one, and then we have 4 to the power of, it's already in base 4, so that is just 2p plus 5. Now the bases are the same, so we can just drop the power. So this is 3 open bracket. Okay, let's just write that a little bit better. So we have 3 open bracket 3p minus 2, and that's going to be equal to 2p plus 5. Okay, now I'm not sure if I have enough space, but I'm going to try to use this up as possible here. So we have 3 times 3p, that's going to give us 9p, and of course 3 times minus 2 is minus 6. Okay, that's distributive law, and then that's going to be equal to 2p plus 5. Okay, now we can definitely go ahead now and arrange the p's together. So we have 9p, and bring that over, we're going to have 2p, and that's going to be equal to, we have the positive 5 over here already, and then this minus 6 will go over and it's going to become plus 6. All right guys, so I've run out of a little space right here. Okay, so 9p minus 2p, that's going to be equal to 7p. Okay, 9p minus 2p is 7p, and that's going to be equal to 6, well sorry, not 6, but in fact positive, oh yes, 5 here, that's 5, that's this 5 right here, plus 6. Okay, all right, so that's going to be equal to, we can just erase this part here and just write 5 plus 6 is 11. Okay, 11. 5 plus 6 is 11. 9p minus 2p, 7p. Okay, so we're just going to divide both sides by 7, and we should get our nice answer that p is equal to, of course, 11 over 7. All right, really good. All right guys, so we are almost done, and I know at this point right now you're feeling good. You're saying, oh yes, I got this, I finally understand. Thank you, Akid, and you're welcome. All right, so let's get into the remaining part of the question. So this one and then this one, and then we're gonna wrap this video up, guys. So here we have, let's zoom it up for you a little bit here. We have 8 to the power of 2x is equal to 1 over 64. Okay, so once again we're gonna have to get them in both into base 8. So here we have, this is already in base 8, so that's 8 to the 2x, and that's equal to 1 over 64, so that's 8 squared. Okay, all right, so there's a couple of ways to do this question, which I'm going to show you both ways because we are experimenting different ways of how to view the question. All right, so what we can do here is that we can cross multiply. That's the first thing that I saw. So we can say 8 to the power of 2x multiplied over here by 8 squared. Remember, we do not multiply the bases. Okay, we just write down the expressions and look at the laws of indices for that one. And of course, 1 times 1 is equal to 1. Okay, 1 times 1 is equal to 1. Now what we have here is that we have right here we have multiplication property. So we have same base, so we're going to add the power. So this is 8 to the 2x plus 2, and that's equal to 1. Now we have a problem. We do have a problem because now what we have here is base 8 and base 1. So how do we resolve a problem like this? This brings us to a very interesting property, which of course a lot of persons at this stage right now, most of the time they get stuck. And here's where Apex Academy is going to expose to you what to do here. All right, so at this stage right here, there's only one number in the world that can give us 1, which has a base 8. And of course we're going to write 8 to the 2x plus 2, and that's equal to 8 to the power of 0, because any quantity, no matter what it is, raised to the power of 0 is equal to 1. All right, so hope that's an enlightener here. If you end up having 1 on one side and some other base on the other side, then of course the 1 can be converted to that very same base raised to the power of 0. Okay, all right, so check out the 0 property. The link is in the description below for that and its proof. Okay, so now that we have the same base here, we have 2x plus 2, and that's going to be equal to 0 because of the equal base property. Bring that positive 2 on the other side, so we have 2x is equal to minus 2, and if we divide both sides by 2, guys, we are easily going to get x to be equal to, we're going to easily get x to be equal to minus 1. All right, so that cancels there, so x is equal to minus 1. All right, so I hope you guys got that. This part was a little tricky, more frightened you for a moment, but thank God for Apex Academy. I can expose you to how that is done. Okay, all right, fantastic. So we're just going to get into the last part, or the last question. I know that this is exhausting, but after this you will never have to have a problem with exponential equations. Okay, all right, so here we're going to get into here. Okay, good. So final one here is that we have, this is 6 to the power of 1 here, 6 to the power of 1 multiplied by 6 to the 5x, and that's equal to 6 squared times 6 to the x minus 7. Okay, it's a little bit longer equation. Now here, multiplication property, 6 to the 1 plus 5x, so that's 6 to the 1 plus 5x. Remember guys, 1 plus 5x is not 6x. 1 plus 5x is equivalent to 1 plus 5x. Okay, all right, here we have same base again, multiplication property, so 6 to the 2 plus x minus 7. Okay, 6 to the 2 x minus 7. All right, so if that's the case, then equal basis property, drop the base, and we're going to rewrite the powers. All right, so the power here is 1 plus 5x, 1 plus 5x, and that's equal to 2 plus x minus 7. All right, so just arrange the variables on one side and the numbers on the other side. So we have 5x over here, and we're going to bring that x over that side, and we're going to have minus x, so this comes over, becomes a negative, and that's equal to, let's leave the 2 over here, and let's leave the minus 7 over here, and we're going to bring this positive 1 over here to become minus 1. Okay, all right, so with that done now, 5x minus x is equal to 4x, And of course, we're going to use some integer skills here. Do check out the link in the description below for how to work out integers. At this stage, I think you're good enough to work this out in your head. But 2 minus 7 is minus 5, and minus 5 minus 1 is equal to minus 6. All right, that's minus 6 there for you. And just to wrap this up now, so 4x divided by 4 is equal to minus 6 divided by 4. That cancels out, so we're going to have x is equal to, we can reduce this. Okay, we could have minus 6 over 4, but it's easier to have basically minus 3 over 2, because that's the solution to this simplification here. So 2 into 4 goes 2 times, and 2 into 6 goes 3. So our final answer here is minus 3 over 2 for this working out. All right, so guys, wonderful pieces of work that we have done here. This looks really beautiful. From my perspective, what do you think? All right guys, so if this video was to your benefit and you finally conquered that fear of exponential equation, please look out for more videos, as we're going to be doing videos on exponential quantities using logarithms and natural functions in the future. Do wait for those videos to pop out if you're in college and university. But for CSEC and CAPE students, this is to your benefit. Do have yourself a wonderful rest of the day. From Apex Academy, we're saying goodbye until next time. See you soon. Bye bye.